everyone. My name is Gary.
And yeah, I'm Davis, and we are both current grade 12 students at St. George's School, and we are part of an organization called Coding Pals.
You go watch your show, please? I'll be there in just a minute.
A little bit introduction for myself. My favorite food is ramen. My hobby is jazz drumming, and my favorite band is Razor.
And so my favorite food is sushi, my hobby is playing the piano, and my favorite brand is, I guess, Google. And a little bit about Coding Pals, I guess. We're an organization that tries to bring free programming education through Zoom meetings to middle school students like you guys. And we have more classes. So if you guys like this and you want to continue learning more about programming, we have other courses that you can find, and there'll be more information about that at the next week, I guess.
So first of all, what is computer programming? Computer programming is a way to give computers instructions about what they should do. And you can achieve a lot with computer programming, as you can know, like, for example, like basically everything on a computer are like coded or programmed. You can do a lot of like other stuff. For example, when making a game, you need to know how to code. If you want to make an AI, if you want to do some solve some problems, like do some simple math as well, those are all like achieved by computer programming. And for computer programming, there are a few different languages. So there's Python, which is what we are going to learn for this workshop. There's also Java, HTML, JavaScript, CSS, C++. Those we're not going to be covering in this class, but if you guys are interested, you guys can do some further research, or you can also join some of our other classes, which we do have classes for all of these.
So people pick Python to learn as their first language because it's a really great language for beginners. So there are a few reasons for this. Firstly, it's very easy to first learn and get started with and understand how it works because as we'll see in, I believe, the next slide, other languages have lots of complicated text, what we call syntax, how the language is written and how the computer understands the code. But in Python, it's very easy and it's very simple to write and both read and understand. Secondly, Python is a very good stepping stone to other languages. So once you learn Python, it's very simple to transition to maybe another language like Java or C++, as Gary mentioned, because once you develop this kind of algorithmic thinking style, first with Python, it's a lot easier to learn another language after that. And also some big companies use Python all the time. Python is very big in things like data analysis and things like machine learning. So people still use Python, even though other languages exist. Python is still one that's widely used today at many companies like Spotify, Netflix, Google, Instagram, etc. So as I just said in the slide before, here are some different ways that we write code in different languages. So the first one is the language called C, and you'll see that it's pretty confusing. There's a lot of like hashtags and like brackets and like a bunch of weird stuff. In Java, it's also pretty similar. There are also lots of words and lots of different things that you have to be careful of, like semicolons and curly brackets. But in Python, everything's just in one line and it's all very simple. And all three code bits in these three different languages. They all do the same thing. They all print hello world on the console. So as you can see in Python, it's very easy to understand and interpret what that actually means because it simply just says print hello world. In C and Java, you have to worry about all of these different things, like including the header at the top in C plus or in C, and thinking about like classes and void mains in Java. So we see in Python, it's very easy to understand and write and learn from it.
And now we'll be learning about pseudocode. So pseudocode is basically universal throughout all the different languages. It's basically like an informal description of the steps that you want to do, and it's basically very understandable with English. And you use it to plan steps about what you want to achieve in your code, basically. So before you write your actual Python code, you can write some pseudocode to help you plan out what you want to achieve, how you want to structure your program. So this is the programming thought process. So this is if you want to like cook some sauce, then you have to first of all open a can using a can opener. Then you have to pour the contents of the can into a saucepan. Then you have to place the saucepan onto this stump burner. Then you have to turn on the correct burner. Then you have to stir, stew, and warm. So it's like a recipe, but like translate it into kind of coding kind of like process.
Yeah, so as Gary said, it with coding and like talking to computers in general, it has to be a very step-by-step process. So actually go with the last slide. If you think about making soup as a human, you might just say, oh, I'll just make this soup by cooking it and then I'll eat it. But with talking to computers, it's very detailed and it's very step by step. So first we have to say, open the can. Second, pour the contents of the can. Third, et cetera, et cetera. And then we have to go through all these very intricate, detailed steps to get to the final part of actually making your soup. Okay, next slide. So to approach a problem in coding, first we have to analyze the problem. So basically that means what is the problem asking for and what does the problem want at the end? Second, design a solution, which is basically the steps I just explained. So taking the contents out of the sauce can and putting it into the saucepan, cooking it, heating it up, etc. All of those very small detailed steps is designing the solution. Then you program the solution, which means you actually write the code on your what we call an editor, which we'll get to that later. That's programming the solution, and then you have to finally test the solution with some test cases and make sure that your code works correctly. So for analyzing the problem, this is the first step. Make sure you understand what the question is asking for and make sure that you have all of the necessary things that you need to solve the question. These will be given to you by the question, and then from the question, you'll know what you need to use to solve it. So it says, for example, variables and functions. You guys don't know what those are yet, but we'll get to that later today. And then next, you have to think of the problem like a computer would, not like a human would. So for the example, y is 7 prime. A prime number means that number has no factors except for 1 and itself. So 7 is prime because only 1 times 7 makes 7. Nothing else, no other numbers times by another number makes 7 except for 1 and 7. So if you think of y7 prime, you might just simply think, oh yeah, 7 is prime because of this reason. But for a computer to figure out that 7 is prime, it would have to test every number up to 7 and multiply them by each other to see if they make 7 or not, because it doesn't just intricately know if 7 is prime. So you have to actually test each single step to make sure that you get the correct solution.
So when you're designing a solution, the writing solution is the most important part when you're solving a problem. So basically, you need to know what steps are necessary to solve the question. So for example, if you want to get the sum of two numbers, obviously you have to first of all get the two numbers that you want to sum. Then you sum it, then you print it out. So that may look like really simple, but here's another example. Finding the perimeter of a triangle. Again, for the triangle, you have to know what the three sides are. Then you close them together and you print it out. But so these two may look like very simple solutions, but if we take a look at the next one, if you want to delete number 3 from the list, this gets a little bit more complicated. So first of all, you have to get the list. Then you have to look through each item in the list. And then there's a condition. So if the number is 3, we delete it. If the number is not 3, we ignore it. But we keep doing this process, repeat until we look through every single item in the list. And then at the end, we can get the new list that doesn't contain 3. So yeah, so even for like a very simple kind of process, the code can get complicated because the computer is very like repetitive. And it's good at doing like repetitive stuff. So you have to give it repeated instructions for it to actually like do a lot of the work that you want it to do.
Okay, so that was a bit of the basics of algorithmic thinking and thinking how a computer would. So now we're going to talk a bit about syntax. So what is syntax? Syntax is basically the small fine details that we need to use for the computer to understand what we're writing. So remember in the slide with the 3 different languages, syntax refers to those like curly braces in the other 2 languages we saw, or quotation marks, or things like semicolons and brackets. In Python, syntax is relatively simple and easy. So that's what makes Python really great to learn first. So it's just the way that the rules that we need to use and follow for the computer to understand what we're actually writing. So while in syntax, it's pretty simple. It's just we need correct syntax for Python to interpret what we're writing and to actually be able to do what we want. And everything kind of starts from syntax. So if you have like a syntax error, that's kind of the main problem that of your code, you have to solve that first before solving anything else. Because if you have a syntax error with your code, then nothing else will work before you solve that error. And syntax is just important for every programming language in general, because you have to follow the rules of each language to run it. But don't worry about that for now. Just worry about the syntax of Python itself, because it's relatively easy to learn and understand.
So let's actually get into some of the details about syntax. So first of all, comments. Comments are basically written words. Like comments, basically it's for documenting your code. So if you write a function, if you write a very complicated function, and then but like later on if you forget about it, and then you're like, oh, what does this function do? Comments actually help you to keep track, basically taking notes of like within the code to tell you which part of the code does what. And it's really good practice to keep some comments in a very large program, because like when you make a really large, like 1,000-line code, you will forget what some of the functions do. So comments are really good for taking note of what you're doing and making marks basically. So comments can be used to explain Python code. Comments can be used to make the code more readable. Comments can be used to prevent execution when testing code. So the third one is kind of a bit more advanced, but you can basically comment out a part of a code, and then basically Python will ignore everything as a comment. Like when you're running a code, the comment doesn't affect the quality of the comments doesn't affect the function of the code at all. So basically in the left side here, you can see there's hashtag. This is a comment. So there's the hashtag. This is a comment, and then so basically this code will not be run. This code will not be run by Python when you run the function. The only thing that will be run is this print function. And over here you can see we have 3 print functions, but they're all commented by this little hashtag over here. So basically all of these will not be run because they're comments. And again, the syntax for comment in Python is basically whatever you put a hashtag, then you can put whatever like English words or code you want, and then it will basically be ignored. And for Python, this only happens in one line. So let's say you have multiple lines of code, right? So if you do hashtag on this line, it will not affect anything on the line up like below it or the line after it. So you have to make another hashtag if you want to comment on like multiple lines. You can do it like side by side.
So next we're going to talk about variables, and this is kind of the basic introduction to actually writing some code. A variable is simply something that holds information or a value, and a variable is created the first moment you assign a value to it. And variables have many different kinds of values, and we call these values data types, and we'll go into the next slide to show some of them. A variable is just something, it might sound a bit like weird or foreign or complicated, but just think about it, that's something that holds information, and each variable has a name and a value. So data types. Different data types are important because they can hold different types of information. So for example, if you want to hold text, so anything like a character on your keyboard or any number, any even symbol like a $sign or %, we use a string. So a string is something that can hold any character on your typable keyboard. For things like numbers, we use an integer if the number does not have any decimals, and we use a float if it does have decimals. For sequences, or what we call arrays, we use a list, so that holds multiple different variables together in a list. That's a bit complicated. We'll get into that, I think, next week. And then a Boolean is just simply a true or false. So it holds one of two states. It's either true or it's false. And here we have some examples. So the first one is a list. So you can see that the syntax involved with this means that it has a square bracket, and then it holds 3 different like words, which are strings. In the second one, hello world is surrounded by quotation marks, which means it's a string. So if you have anything surrounded by quotation marks, that's what defines a string, and it can hold, remember, any characters or any text you want. On the next line, 5 is an integer, so it's just an integer number, which means it's a whole number. Next line, 5.55 is a float, which is just a decimal number. And then we have another list for some reason, holding numbers. And then at the last one, we have true, which is a Boolean. So I saw a question saying, what does Boolean mean? Boolean just means it's either true or false. So it can only be true or false. And in this example, at the very bottom, it says true. So this Boolean would be true. So these are just some different kinds of data types that we can use in Python, and they're helpful because they allow us to do different things with our variables and with our code.
And how do we create a variable? So this is also more syntax stuff. So by setting a variable name on the left with the equal sign in the middle and the value on the right, we can create a variable. So here are some examples. So and again, Python is very like beginner friendly, which means that you don't have to declare what variable you have. So when you like later on, after you learn Python, you learn some other languages, you might notice that their declaration is a bit different from Python because those languages are like a lot more stricter, are a lot stricter. But for Python, at least, all you have to do is basically you have a variable name, so you can name it whatever you want. Then you need the equal sign. Then after that, you just need what data you want to store into this variable. So again, all of the things are from right to left. So basically, whatever you put on the right side of the equal sign, it will be stored in the left side, in the left variable. And again, these are just comments. So if there's a comment just shows you what they do. Like it's fine if you completely don't write them. It's just more readable, but it's fine if you completely just like don't write these comments. So here we have some examples. First one is obviously integer. So 10 is an integer, so we have a 10. And then the last one here, we have a float because there is a decimal point here. So anything with a decimal point, again, is a float. And the Boolean, just either true or false. So if this is replaced by false, but this is still a Boolean. And the last one is string. String, you can basically understand, it's like a combination of different characters, so different letters. So it can be like an English phrase, English word. It can also have like numbers in it if you want. You can have like symbols in it. So basically, string is like a combination of like anything. So you can have like, for example, 1, 2, 3, A, B, C. This is still a string because it's like basically a combination of different characters. If it's just 1, 2, 3, then that will be an integer. But if you add an A behind it, that means it has to be a string. Also, if anyone has any questions, anytime, just feel free to put it into the chat, and then we'll answer it as soon as possible. And why use variables? So variable actually basically lets us do most of what we like can do in coding, and they're a very crucial part of everything. So if we use the same variables, values in multiple places, but want to change it later, it can be hassle changing each value. So we can simply use a variable instead and change the value of the variable once they implement these changes throughout our entire code. So it might sound really complicated, but basically the essence of it is, let's say you have a number 5, and you have a function that basically makes it you have to like multiply it by 5 minus 3 divided by 2, like to the power, all to the power of like 10. So if you have a function that executes like what this thing outputs, like every single time when you change it, like when you change the variable, like you have to manually do all of these again. So you have to do, like, next time you have to do like 7, next time you have to do 8, you have to do all of these again. But if you just put x in there, all you have to do is to change the number x. So you have to make, like, let's say x equals to 7, you have to make x equals to 8. And then after you do that, then that means you don't have to change anything in the base code. So if you have x in there, you can just like literally just replace what the x value is, what the x variable is, and then you can get the desired output. So variables are basically there to prevent like they're really flexible, and they're there to prevent I guess like duplicacy of your code. And also, yeah, being able to reference variables in multiple places is also what makes them so useful. So you might need, let's say, yeah, again, you have a number 5 here, but if you want to reference this 5 over here, you have to know that it's 5. So when you're writing the code, you have to put multiple 5s in there. So basically, let's say you have different functions, you have multiple stuff that require to use 5. But then if you want to change them all at the same time, you have to individually change them to like a 7, to a 7, to a 7, to a 7. But if you have like say 4 x's on the in your code, and you want to change them all at one time, all you have to do is to change x equals to 7, and then all of these will be changed. So for example, we can directly put variables to the console. So console is another concept that we'll talk about later. It's something that's specific to Python. But basically, these are what we type into the console, right? These are what we type in the console. So basically, first of all, we do name equals Davis. So now, Davis variable, the name variable actually stores the value of Davis. And this is also a reminder, this is a string. Since this is a combination of different characters. So if we do print name, so again, the name is what we use, the variable name that we use that stores Davis. So basically this will be interpreted as print Davis, since Davis is what's being stored in the variable. So it'll print out Davis in the console. And then what if we change the name to Gary? Oh. Change the name to Gary. But now the name will basically delete the Davis data and then store Gary inside the name. So now if you execute the same function, so notice that these two are the same. It will actually output the Gary on the console because currently what we store is Gary. And also when everything executes code, it'll always go from top to bottom. So it will execute whatever's on the top first, then the second line, the third line, then the fourth.
Okay, so a bit more about variables. So if we want to perform like math in Python, that's also possible. So mathematical rules still apply in Python, but just a reminder, you can only do this with the number data types like integers and floats. You can't do like math with like strings because they're characters, right? They're not numbers. So, but for an example, if both of our variables are numbers of the same data type, we can add them using a plus sign. So first, actually, let me annotate. So in our first line here, we're setting the variable of x equal to a 10, and this is an integer because there are no decimals. Next, we are setting the value or the variable called y to be equal to 5, which is also an integer. And then here on the next line, we're printing out x plus y, which ends up printing out 15 on the console because 10 plus 5 is 15. And you could also like make a new variable if we want to call it like z is equal to x plus y. Because x is 10 and y is 5, this would store the value of 15 into z. So this means, one second, I'm just writing this out. This means that if we were to print out z, like we print out x plus y, it'll give us the same value because this new variable z also holds the value of 15 because it's the sum of x plus y. So this is just an example of using math in Python. Other things like subtraction, multiplication, division, and more mathematical operations all apply in Python, but just to make sure that they are both numbers and of the same data type. Sorry. So Python arithmetic operators, I realize that might sound a bit scary or confusing, but it's actually not that bad. So as we just saw with the last example, first we have just x plus y. So this is just an example of addition. We also have subtraction, multiplication, which is represented by the star sign instead of like the typical x you would see, because x is obviously a letter on your keyboard. So they change it on a computer. So multiplication is actually the star. And if you hold shift plus 8, that's how you'll get this star sign. Division is a slash instead of the typical division sign you'll see like like this. So for the same reason, that division sign doesn't exist on the keyboard, so we have to change it to something else. So that's why we use this slash for division for. So all of these are pretty basic things that I would assume you have probably heard of before. And the last three, they're not so important because we won't really be using them. When we have modulus, so that's kind of a remainder. If that doesn't make sense to you, then don't even worry about it. Exponentiation. So this is something like 2 to the power of like 3. I'm not sure if you guys have heard of this before, but that's basically 2 times 2 times 2 because it's 2 times itself by 3 times, which would be 8. This is also not too important because you can just do that with multiplication by itself anyway. And floor division is something that we use to, when we're dividing like 5 divided by 2, the answer is essentially 2.5 because 2 goes into 5 2.5 times. And I realize that some of you might have not learned about this yet, so don't worry about this if you haven't. But floor division essentially means we cut off the part after the decimal. So the answer in floor division would just be 2. So if we did 5 floor divided by 2, then the answer would only be 2 because it cuts off the decimals and it rounds down by default. And I didn't explain this on the last slide, I think, but you can also add numbers to, or like change a single variable itself. So I think it's on the next slide, so Gary can cover it. But yeah, you can add numbers to a variable itself after you've already defined it as well.
Yeah. Over here we have some more. So these are called assignment operators. These are not necessarily called math operators, but they also do math stuff. So there's the assignment operator. So basically, all of these are assignment operators, but basically the equal sign is very different from a traditional equal sign that you have in the math class. So we all know that in math class, right? If we have like x equals to 5 plus 3, then you know that x equals to 8. But that's not how it works in code. Basically, how it works in code is if you have like x equals to 5 plus 3, then you know that we're giving the value 5 plus 3 2x. So this is x equals to 8. So right now x equals to 8. I mean, but this may look the same, but it's actually pretty different because over here you can see you can do something like x equals to x plus 3. So if you do x equals to x plus 3, which doesn't make sense if you like do normal math, because this would like both x's will just cancel out and it'll be 0 equals to 3, which doesn't make sense. But what it's actually doing here is it's giving the value of x plus 3 into x. So again, the equal sign doesn't behave the same as it does in math. So right now we have x equals to 8, and then it sees that, oh, it wants to do plus 3. It wants to do x plus 3. That's 11. So I'll assign 11 to x. So basically, yeah, all of these have the same basic properties. So basically, what you do is you add an equal sign behind all of the operators that Davis mentioned in the last slide, and then they'll achieve basically these kind of things. So for x plus equals to 3, it'll basically add 3 onto x. For x minus equals to 3, it'll basically minus 3 from the current x value. So if x is 8, it'll be 5 right now. If x multiplied equal to 3, that means basically you're multiplying x itself by 3. So now it's 24. If it starts from 8, 24, then this is divided by 3. So this will be 8 over 3. So mod 3. Modulus is the operation basically that gives out the remainder. So if you do x divided by 3, technically it equals to 2 remainder 2. So remainder is a thing that's also really useful, but for now, I don't think it's necessary to really understand how it works fully. But basically, just to get the remainder, modulus is to get the remainder of the operation. And again, the double divide, the floor sign, the double divide thing, basically just removes the decimal point. So if it's 8 divided by 3, it'll be 2. Then x multiplied by 3. I'm sorry. Square, to the power of 3. So if it's 8 right now, then to the power of 3 will be 64 times 8. 5, no, sorry. It would be 516, I think. Okay. Wait, is it? No, five false. Five false. Yeah. So but yeah, basically these are all those timer operators. They basically behave the same as arithmetic operators, but basically it just like assigns that value, updates the x value to the new operator, to the new value.
Yeah, so just before we move on to this, because after we go through this replit setup, you guys will have some time to look at and play with code on your own. Just the big thing to remember is when you have the variable and then the value on the right. So let's say we just like make it like 8 plus like 7, which is 15. The thing on the left-hand side is the name. So I just wrote var here to represent like variable name. So the thing on the left hand is always the name, and the thing on the right-hand side is always the value you are setting the variable name equal to. So in this case, the variable called var, maybe that was a bad idea. It has the value of 8 plus 7, which is 15. So now var will hold the value of 15. So now we say that var equals to 15. Now, if we want to add like 3 to this, if we write var is equal to var plus 3, this is essentially saying we're setting the value of the variable called var to be equal to the variable called var plus 3. So right now, the variable called var holds the value of 15, and we're adding the value of 3 to it, which means that we're setting the variable called var to a value of 18 because it's what the current variable already is, 15, plus another 3. So the big thing to remember when you guys play around with this on your own is that the left-hand side is always the name of the variable or what's being assigned, and the things on the right-hand side are what the value you are assigning to the variable actually is. So yeah, let's move on to replit setup. So replit is essentially just a way that you can write your code, and we use replit because it's easy to set up and it's easier than downloading a bunch of software onto your computer, because on replit everything is hosted online. So replit's what we call an integrated developer environment, or IDE, and it's just a place that you can write your code for everything to work. Typically you would download something onto your computer and then run it from your local computer, but with replit you run online on this website. So right now, if everyone could please head to repl.it and follow the steps to sign up, and then please say when you're done in the chat so I know when people are finished and can move on. So head to this link that's on the slideshow right now, repl.it, and press sign up on the top right corner, and then choose the way you want to sign up. You can do it with Google or make your own account with your email. But when you guys are done making your account, please come back and say something in the chat. Okay, a few people are done. I'll wait for like maybe 1 or 2 more. And then if you guys are currently on this next slide, actually, Gary, let's just go on to the next slide. So this next slide is basically confirming a bit about yourself, or like saying that what language you want to use. So just write a bit about your profile information, such as like your skill level and what you're interested in. And then for the picking what languages you're most interested in, pick at least Python for one of them, and then you can pick random ones for the others. This might actually be a bit old, so they might have changed the way sign up works, but it should look something like this. So make sure that you at least pick Python for one of your primary languages, and then you can pick whatever you want for the other 2. So after you do the sign up, you should see this like kind of blank screen. On the top left-hand corner, you should see the option to create a new REPL. So it should be like at the very top left. And if you press new REPL and then you select Python as your language, we'll help people who are not there in a second. So if you guys need help, just say in the chat. You press new REPL and then you select Python as a language from the dropdown for your REPL. Name it and then press create REPL. It doesn't matter if it's public or private, so don't worry about that. Just press create REPL and then next slide, Gary. After you create it, you'll see something like this. So on the most left-hand side, you'll see all the files, which in this case is only one because we only have what we call the main file, which is like the main significant file. In the middle, that's the actual file itself, and you write your code in that file. So where it says not sure what to do, blah, 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 that's where you write your code. And then if you press run at the very top in green, whatever's in your code will run and it'll compile and it'll like execute. And then if you print something, it'll show on the console. So right now, if you're done the setup and you have your REPL, we'll give you guys like 5 to 10 minutes to basically just play around with what we learned so far, because it's been like quite a bit. So you guys can work playing around with variables and print statements and trying to just a little bit with the Python editor up by yourself. And also, if you guys need help, this will be the time that you can just ask in chat if you need help with setting up Replit or setting up anything, and we can try and help you with that. So yeah, we'll come back in like, I don't know, maybe 5 to 10 minutes or after everyone is done setting up. So how do you choose Python? If you're still needing help with that, just say it again. I'm not sure if you're talking about for the REPL or for your sign up profile.
I think the screenshots are from an older version of REPL. Because you
Yeah,
don't
it
have
could be.
to
Oh,
put
is there
in.
no
Mm-mm.
option to select the language anymore?
No.
Okay, then don't even worry about it. You can just proceed to the next one without selecting Python. But yeah, if anyone else needs help, you can just say it now in the chat. Otherwise, just feel free to play around for like 5 minutes, I guess, and we'll come back after that. Okay, I hope you guys had some time to figure out and work with Python with your own IDEs. But now let's come back and we'll continue with some more slides.
So first of all, we'll learn about if statements. So if statements are very good at evaluating whether or not to execute a function. So in Python, if statements are used for decision making. It will run the body of code only when the if statement is true. So for example of this will be, let's say, if today is raining, then we have to bring an umbrella. But if today is not raining, that means we don't bring an umbrella, obviously. So basically, when you make these kind of decisions in life, or like these kind of small decisions in life, you kind of go through if statements like, oh, it's raining, I'll bring umbrella. So basically in code, these are called if statements. And when you want to justify one condition while the other condition is not true, then you have to use if statement. So yeah, for another example would be if today is snow. I mean, if today is cold, I would wear like a jacket. So these are the conditions. These are the things that we kind of process in our brain without really thinking much. But in computer, you have to write them out as if statements. So and also note about syntax for Python specifically is indentation. So indentation basically means the spaces at the beginning of a code line. Python uses indentation to indicate a block of code. So everything that's indented is considered a part of the if statement. So you can have the if statement, and then you see this little area here that's like indented. This part, basically that space tells Python that, oh, well, I belong to, like, this code belongs to this if statement. So anything that's indented over here will all belong to this if statement. But if you write like something else here, if you write like another new line of code here, this will not be a part of this. This will not be a part of this. So no, most cases, your IDE will like help you indent automatically. But sometimes like a lot of people like often just like forget about it or mess up, and then that tend to cause some troubles. You must have a semicolon. You must have a colon at the end of if statement, not a semicolon.
Yeah, just say colon.
So basically over here, you can see there's a colon here. Basically, it tells the computer that, oh, you're going into the code block of an if statement. So basically, on top of the indentation, you need a colon. So it's not a semicolon. There's a typo here. But so here's an example of an if statement. So the flowchart is kind of for you to understand it better, but normally you don't really have to draw a flowchart. So for example, first of all, we assign true to the flag value. So now we know that the flag is true. So if true, so if the flag is true, then we print welcome to coding files. So we have these three things. The output will say welcome to coding files. So in the flowchart, you can see basically the condition here means basically the condition here basically is the if statement over here. Then if it's true, it'll go into do this. But if it's false, it'll just go like right into the code. So basically both of them will end up here. It's just like which path you will take, whether it's true or false.
Okay, so this is the else if keyword in Python, abbreviated to elif. So elif is the way to check another condition if your previous condition was checked to be false. So here we can see that we're setting the value of A to be 33, the value of B to be 33 as well. And then we're saying if B is greater than A, which is obviously not true. By the way, this statement right here, which is right after the if sign and before the colon, is called your condition. So this condition is obviously not true because A and B are the same. They're both 33. But if this were to be true, we would print out B is greater than A. But since it's not, this else if keyword says, oh, because the first if statement was not true, let's check the next if statement. Next if statement says, if A is equal to B, then we'll print out A and B are equal. And obviously, because they are both 33, they are equal, and it'll print out A and B are equal. So this else ifs, this condition will only be checked if the first one is not true. So let's say instead of 33 for B, we had like 40. So let's say B is 40 and A is 33. Now, if we run this, how do I erase? If we run this statement again, we'll see that B is in fact greater than A because 40 is greater than 33. And then in this case, we would print out B is greater than A, and then this code would run. Then we would skip the else if statement because the first condition was already true. So we skip the else if statement and we go directly to the code, to the code that follows afterwards, after the else if statement. So the else if statements are our way of checking another if statement after the first one, but do you need a double equal sign? We'll get to that in a second. The else if statement only runs, or it only checks the else if statement if the first if statement is not true. And the same goes for multiple else if statements. So you can actually stack as many else if statements as you want below the first if statement. But just remember, they all have to say elif, not if. So you can have as many as you want going down, but they will only check in the order of the placement because Python reads your code from top to bottom. So if any one of them is true, it'll run the code inside that and then it'll skip to the part after all the else if statements. Actually, I'll just talk about this right now. This double equal sign, it's also here. So because, as we said a bit earlier, if we want to make a variable called like x is equal to 10, we're setting the value of 10 to be equal, or we're setting the value of 10 to the variable name x. So because we already have this use case of one equal sign in Python, the way we check for equality is actually different. So here, if I wanted to check if like x is equal to 5, I can't do one equal sign. This won't work because what this is telling the computer is that it's trying to set the value of 5 to be x, because the way we've defined assignment earlier is that if we have one equal sign, we're setting the value on the right to be equal to the variable name on the left. So if we want to check for if x equals to 5, we can't use one equal sign. So instead, the way we get around that, the solution they came up with, is by using just two equal signs. So if you ever want to check if a value equals to something else, you always have to use two equal signs, not one equal sign. And obviously, if you like print out something, whatever, this wouldn't run because x is not equal to 5, is equal to 10. But for checking for equality, you have to use two equal signs. For checking or for assigning a variable value to a variable, you have to use one equal sign. So that's just a bit of a nuance to remember. And it's just a kind of like a syntax thing in almost every single language. And yeah, we're already here. So I guess Gary can talk about else statements.
Oh, sorry. So else statements are basically what you will execute if no conditions are met. So over here we have the same if statement. So if A is bigger than A, if B is bigger than A, then we say B is bigger than A. If A equals to B, that means A and B are equal. But what if it doesn't meet any of these conditions? That means that if A is not smaller than B, so if this is false, and if A doesn't equals to B, but this is also false, then the last possibility is that A is bigger than B, right? So we have over here else print A is greater than B. So basically, if the statement doesn't go into, so if it doesn't go into any of these two, if it doesn't go into any of these two conditions, then it will just go into the last one where it says else. Oh, then we just do this thing. So yeah, that's basically else statement. And then we can also learn about nested statements. So you have if statements within if statements. You can have as many like if statements within an if statement as you want. Basically it'll just like do additional filtering. So over here we can see if x is bigger than 10, we'll say above 10. And then if x is bigger than 20. So notice that the indentation here, notice that these are all still within this if statement. So basically if x is not bigger than 10, it will not execute any of these. It'll just basically just go to the end and then like execute whatever the code is like afterwards. So if x is smaller than 10 here in this situation, that means it'll just skip this entire thing. But over here we can see that x is 41. That means we can actually go into this if statement and we'll check if it's also bigger than 20. If it's bigger than 20, I'll say, oh, it's also bigger than 20. But if it's like, let's say like 10 to 19, or if it's like, 11 to 19, that means it's not bigger than 20. It'll say, but not above 20. So it'll say above 10. Actually, no. So it'll just say above 10 over here. And it'll say whether or not if it's also above 20. So these are nested if statements, and you can have as many nested if statements as you want.
Gary, can you jump to Replit really quickly? I just want to give some examples. Okay, so you guys should be kind of familiar with this environment now, and I'll just write some code so that maybe this makes a bit more sense if it was just a bit confusing during the explanation. So let's say we have two variables. We'll set A to be equal to like 15, and then let's say B is equal to 20. So we can check here if B is greater than A, we'll print out B more than A. Then we'll say elif A is equal to B, we'll print out here we'll say equals. And then here for the last statement, the only other thing that could be true is if their A is greater than B. But just for the sake of example, I'll use else right now. So then I'll say A more than B. And then at the very bottom, we'll print out like two things. So like shows when it jumps to the next line. Let's say like hello world. And then let's say like UBC. So with this like logic, any single time your any time any of these statements is met and the code inside the block runs, the rest of them will be considered like not there anymore, and it'll jump to the next line. So here we'll see that if we press run at the top, it prints out this, it checks this first if statement, and then it says, oh, B is in fact greater than A. This is true. So we'll print out B is more than A. Then after that, because this condition in this statement was true, we ignore these other two and we go directly to the code afterwards, which is printing hello world and printing UBC. So that's why you'll see on the console, it only says B more than A. Maybe to give a better example, let's just say we have one variable actually, and we'll say if A is greater than 10, we'll print more than 10. Else if A is greater than 7, we'll say more than 7, etc., etc. Because in the last one, all of the conditions could have been, only one condition could have been true, but here we have more than one condition that's true. Else, let's just say like A is small. So here, because A is in fact greater than 10, we'll see that it prints more than 10. Then it doesn't check this next statement if A is greater than 7. It doesn't check this next statement if A is greater than 5. And it doesn't check the other statement either, because this first condition was already met. Now, if we set A to be equal to 9, which is not greater than 10, we'll see that if we press run, it'll only print out this second statement, because first it checked this first statement. A is not greater than 10, so it moved on to the first else if statement. Now we're checking if A is greater than 7, which is indeed true. That's why it prints out more than 7. And now because this condition was met, we skip the last two conditions, we ignore them, and then we simply go to the code after this entire if block. So that's why it says print more, that's why it prints out more than 7, then it prints out hello world, then it prints out UBC. So this is kind of the basics of how code works. And then there was already an example on nested ifs. So we can go back now and do, I think, a practice question, or maybe talk about some operators first.
Yeah. So yeah, we'll also be taking a look at some comparison operators. So okay. Yeah. So for comparison operators, basically these are what we call logical operators. They basically compare like two different values. So these are really common. And if statement, you can say if this is equal to this, if this is not equal to this, if this is greater than this, that means we'll execute this. So over here we can have our few. We can take a look at our few operators. So equal sign, double equal sign. Again, we already explained this. This is equal. So basically, it checks whether two values are equal. If it's 5 and 5, that means it will return true. If it's like 5 and 4, if it's 5 and 6, it will return false. And also, all of these operators return like a Boolean value. Basically, it's either true that this is true. It's either that this is true, or it's either that this is false. So it doesn't equal to means that not equal. Again, if these two are not equal, if it's 5 and 6, it will return true. If it's 5 and 7, it will return true. If it's 5 and 5, that means they're equal. That means the return is false. Greater than and less than. So again, really self-explanatory. It's like basically the same thing as it does in math. If it's greater than this, if it's less than this, then it will return true and false. But keep in mind here, this is different from these two. So the greater, so in the case of let's say in the case of this one, so the greater than, so let's say we have 6 and 5. So we have 6 and 5. 6 is obviously bigger than 5, right? So it will turn true. But if we have 5 and 5, the 5 is actually not bigger than 5 because it's definitely not bigger than itself. It equals to itself. So that means this will actually return false. Whereas for if it's 5 bigger equals to 5, over here, it'll actually return true because it counts the condition that's greater or equal to. So 5. So if you do 6 bigger equals, if you do 6 bigger equals to 5, it'll still return true because 6 is obviously bigger than 5. So this is the one, like, basically one difference between these two comparisons, but yeah. And there's also logical operators. So these may be a bit hard to understand, but once you get around it, it's pretty simple. So basically there's and, or, and not. So these are for comparing two different Boolean values. So these are used to combine different statements together. So logical operators, they combine different conditions together. First of all, and, so basically it returns true if both the statements are true. So if x is bigger, if x is smaller than 5 and that is bigger than 10, then it will return true. So let's say if x equals to 3, it will definitely return true because it checks both conditions. If x equals to 5, it will actually not meet the first condition, but it will meet the second condition. So, but this will still return false. Again, the first one returns true, but the second one actually returns false because it doesn't meet both of the conditions. And if it's like 10, then it doesn't meet either of the conditions, still false. So and means that you have to satisfy both conditions in order for it to actually return a true. And for or, it can return true if only one, like if at least one of the statements is true. So you can see it's either 5 or 4. So if x equals to 3, it'll basically return true because both of them are true. If it's equals to 4, you can say that it satisfies the first condition, but doesn't satisfy the second condition, but it'll still return true because at least one of them is true. And then if you do x is 5, neither of the conditions are met, that means it will return false because none of them are true. The last one, not, it basically just means like the opposite. So if you have a condition like not, like let's say whatever in here, if it's like sums up, if it evaluates to true, if whatever's in here is true, that means it basically returns false because like not true is false. Similarly, if it's not false, it will return true. So yeah, these are the different logical operators. Again, these are pretty self-explanatory. The comparison operators are pretty self-explanatory, and the logical operators you have to kind of like think about it, and then so and you have to satisfy all of them, or is you only have to satisfy at least one of them. Not it's just turning the opposite.
Okay, so we were going to do a practice question right here, so you guys are a bit familiar with if statements, but we're going to run out of time, so we actually have to skip this and go right to the next segment, which is loops. But that was a website. We're skipping the break as well. Sorry. That's a website. Dmod, we'll go back to it later. It's just a way that we can practice our coding skills by solving a few questions, and we'll get more onto that at the end of class. But today we have to kind of just skip through that and go to the next part, which is loops, because otherwise we're not going to have enough time to finish it. So quickly, what are for and while loops? In Python, loops are things that repeat the chunk of code inside of them for a given amount of times. So a while loop is a loop that executes the code inside of it while a condition is true. So it's kind of like an if statement at the end of every single, actually, they're both like if statements. At the end of every single iteration of your loop, you go back to the top and check the condition of your loop. If that's true, you keep running. If it's not true, you break the loop and you go to the next segment of code underneath the loop. This is particularly useful when we don't know how long we're looping for specifically, and we have to follow a condition. On the other hand, for loops are loops that run for a set amount of times, and that's defined when you make the for loop. So they can also be used to go through sequences, to go through strings, to go through lists, and we'll later learn how we can iterate through those things. And loops, most basically for loops, they iterate through a number of repetitions, or what we call iterations, and that's defined when you make the loop. And why use loops? Quickly, they help us repeat things without having to write the code multiple times. So it's much more simple to like write it in one loop rather than pasting it like 5 times over and over again. And we have also a bit more syntax. Just like if statements, you need to have a colon after the definition of your loop. And then everything that's indented will be considered part of your loop, and everything that's not indented will be considered that's not part of your loop. There's an if statement here, but the same thing if you had a for loop. So pretend this is a for loop instead. Everything within this indented block, any code you write that's indented will be considered part of the for loop. And then if you unindent your code, that's the end of your for loop. And then this is back to normal code.
So let's talk about while loops. So while loops are easier than for loops. So while loops are declared in a similar way to if statements. So if you know how to do if statements, then while loops should be easy for you. So the most basic method requires an integer, so which is decrease. So basically, you just need a condition here. So instead of writing if and it's smaller than 5, you'll do while and it's smaller than 5. Then you will do all of these operations until it ends. So the most basic method is an integer, which is increased each time the loop repeats itself. So for example, in the following code, the number 4 is printed out 4 times. So first of all, you have number, so n equals to 1. So while n equals to smaller than 5, so right now it is because 1 is smaller than 5. It will print out 4 once, and it will add 1 to, again, this is the addition operator. So it will add 1 to n. So now n becomes 2. Let's check that 2 is still smaller than 5, so it will print out 4 again. Then it becomes 3. So now this checks that 3 is still smaller than 5, then we'll print out 4 again. Then it becomes 4. 4 is still smaller than 5, we'll print out 4 again. Then we meet 5. We see that 5 is no longer smaller than 5. That means we will end the entire while loop, and then we go on to the next part of the code. So again, a very common mistake that people make are they make a while loop that like basically runs infinitely. So you don't change the condition. So like the condition is not being broken. That means if it runs infinitely, that means your computer is gonna like break. But like most of the cases, the program will actually stop you from doing that. It'll basically say, "Oh, you ran into an infinite loop. Like we stopped the program for you. This is like this is the line where it happened. This is what you have to fix." So basically, a lot of time your computer tells you where it broke, and then it will just like you just have to fix it. It won't actually like break your computer. And then for loops, yeah. For loops, basically, the range function, the most basic way to use it and the most also common way to use it is the range function. Range basically gives you out a list of numbers. So it will start from 0 by default, and then it will increase by 1 every single time, and then returns each number into an number. So for example, range 6, it will be 0 to 5. Notice how it doesn't include 6 here because basically you're telling it to run 6 times, right? But if we count from 0 to 5, you can see that there's 1. So there's 1, 2, 3, 4, 5, 6. 0 to 5 is actually 6 numbers instead of 5 numbers. So basically range function will return the 0 to 1 less than the number you inputted. So over here, this function specifically will print out 0 to 5. Because you're running from x in range of 6, so it's 0 to 5. So every single time you run x, you run this for loop, it'll print out what the x value is. So in this case, it'll go from 0 to 5. So that's pretty self-explanatory. And then another way you can use the range function, you can also declare where your number starts at. So if you do this is basically the same thing. It'll say it'll start at 0, it'll end at 6. So again, this will output 0 to 5. So you print out 0 to 5 again. But let's say if I want a range function that says if I want to print out, let's say like 100 to 110, then I have to do a range 100 to 111 because for 111 it actually ends at 10. So basically this will print out the range from 100 to 110. And we can also use for loop. With for loop, we can execute a set of statements. So one for each item in the list, tuple set, whatever. So here's a list which we haven't talked about. I think we'll talk about it next class. But basically, the list is like a series of different items. Like it can be a series of strings, it can be a series of numbers, it can be a series of different stuff. So over here we have for x is in fruits. So fruit refers to the list that we have already here that has all of these values. So for every x in fruit, we print out x. So basically, we iterate through each of the items. So first of all, we have apple, then we have banana, then we have cherry. So we'll print out apple, banana, cherry accordingly. And then for x in banana, we print out x. So this basically means that we're printing out each single letter from the string because a string is regarded as a combination of different characters. So again, basically this is like a combination of different characters. So basically if you do this, you'll basically print out just like every single character. Like you'll print out B first, then A, then N, then A, then N, then A, and then you're done. So basically it's the same thing as printing to like straight up printing out like banana. It's basically the same thing as printing out this, but like you're just doing it for loop, which you might need to do it sometimes. Like sometimes you might have like only want, let's say, the second to the fourth letter of banana. So yeah, there's some use cases for that.
So the last thing we'll do for loops is breaks and continue statements. So if you want to exit the loop at a certain time or at a certain point, we can use an if statement and then check if that condition is true. And if it is true, then we'll break. So on the left-hand side, we have for x in range of 6. So remember, it goes from 0 to 5. If we print out x, it'll print out 1. And then every single time, actually, I'm going to annotate. So on the first iteration of the loop, x will be 0. We'll go through everything. We'll print out x. So we'll print out 0 to the console. If x equals to 3, which it's not, we skip this because it's not equal to 3. And then we go back to the beginning of the loop. And now x is equal to 1. So now we have x equal to 1. We print out x, prints out 1. Is x equal to 3? No, it's not. So we ignore this condition. We ignore the code inside of the if statement. We go back to the top. Now x is equal to 2. Print out x on the console, print out 2. Is it equal to 3? No. Go up to the top again. Now x is equal to 3. So we print out x, print it to the console. Now we check again, is x equal to 3? And it is, which means that afterwards we break. And now with the break statement, what it means is that we just stop repeating the loop. Instead of repeating the loop again, we go on to the next chunk of code after the for loop is done. So once the break statement is hit, we end the loop and we go to the next part, the next segment of code that's after the loop. So yeah, you should typically check your use break statements with if statements, because otherwise you're just going to break after like just one iteration of your loop. And on the right hand side, we also have the while loop. So first I equals to 1, and while I is less than 6, so this is our condition for our loop. We print out I, and then we're checking if I is equal to 3. This does the exact same thing as the for loop, so I won't go through all of it again. But we add 1 to I, then we go back to the while loop, blah, 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 continue until I is equal to 3. Then we check is I equal to 3, and then it's finally true. Then we will continue to the rest of the code underneath and finish this like while loop. And next we have continue statements. So continue statements are a little bit different from while loops, or no, continue statements are a little bit different from break statements in the idea that they just skip the rest of the code that's in the while loop. And after this continue statement is hit, it goes back to the top instantly. So to demonstrate, we have this while loop on the left-hand side. We start with n equals to 1. And so while n is less than 5, we add 1 to n, check if n is equal to 3. If it is, then we continue. Otherwise, we print n. So while n is less than 5, so let's go through each single step here. We add 1 to n. So now n is equal to 2. Is n equal to 3? No, it's not. So then what we're going to do, we're going to print n. So now let's keep like a log of things printed here. So we print out 2 because right now n is equal to 2. Now we go back to the top. Is n less than 5? Yes, it is. So we'll go to the next iteration of our loop. We add 1 to n. Now n is equal to 3. So n is equal to 3. Now we go to this if statement. Is n equal to 3? Yes, it is. So what we're going to do, we're going to continue. So instead of going through the rest of the code in the loop, we're going to jump back up to the top and skip all of it. So instead of printing out n, we actually skip it because of this continue sign or this continue keyword, and we go back to the top. Now is n less than 5? Yes, 3 is less than 5. So what we're going to do, we're going to plus 1 to n. So now n is equal to 4. We check again, is n equal to 3? Well, 4 is not equal to 3, so we skip the condition, or we skip this code inside of the loop or inside of the condition, and we print out n. So now we print out 4, etc., etc. We're got like 10 minutes left, so we'll move on to the question, I think, on the next slide. And this is just another example of a continue statement. So basically, continue is just used to skip things in a loop if you don't want a certain thing to happen. So here, if you can quickly just read this, this will essentially just print out everything in this fruits list except for banana, because with this banana, it checks for this condition if it's equal to banana, and if it isn't, it's continuing. So the continue is pretty useful, as well as break, to manipulate our loops in certain ways that make it easier for us to do what we want. So breaks and loops are especially useful for while loops, though, I would say, because they allow us to have more control over our loop in general. Yeah, so we're moving on to solving a problem now. A junior 1 problem refers to the junior problem on the CCC, which is the Canadian Computing Competition, which is just, well, It's a contest for programming, which you can just test your skills and try to solve some questions. There are 5 questions in total, and the junior one is the first one. So we did not talk about inputs yet, but we'll do it shortly with this example. But an input is just a way that we can take in information from the user, and you can type something on the console, and then you can assign it to a variable. We'll go into that shortly. And then we can determine what we need to use to solve the question. So if statements or while loops or for loops, and then we make the calculation, and then we finally print out the solution. So on the next slide, we have a link to a question, and we can quickly just go over it and quickly solve it.
And I posted the link into the chat if anyone wants to look at it along with us.
Yeah. So the question says, a vote is held after singer A and singer B compete in the final round of a singing competition. Your job is to count the votes and determine the outcome. So the input will be 2 lines. The first line is the variable V, which is the total number of votes. And the second line is a sequence of V characters, each which is A or B, which is a character representing the votes for a particular singer. And then the output specification, which is what it wants us to print out. It says the output will be one of 3 possibilities. A, if there are more votes for A than there are for B. B, if there are more votes for B than there are for A. And then a tie if there's an equal number of votes for A and B. So by analyzing this question, we basically understand that what they're asking for is for us to take in this first input, which is the number of votes, and then the second input, which is a string of each vote. And then what they want us to do is count them up and see if A or B has more votes or if they have the same number of votes. Also, this website is Dmod, which is something that we use to submit our code to be graded and to test if it's right or not. And you can sign up for an account later because we have to quickly solve this problem and end class. But yeah, you can jump over to Replicate Gary and you can just go through a solve.
Yeah. So we know that we have 2 inputs. We have a number input, then we have a string input. And we know that basically the first input, it tells us how many votes there are. So it tells me how many letters there are on the second line. So obviously the first thing I have to do in this situation is to take in an integer input. So I'll just say count, or count of like how many votes there are, right? So count equals to, again, we do input, but over here, because we're doing it. So for inputs, we use the input function like this, but this will only return us a string. So it'll take in all of the inputs like line by line, but as a string. So I have to cast it into an integer. So I have to make sure that we have to tell it as integer. Again, it's something that's only like when you're taking inputs, you have to cast.
Actually, yeah, just to quickly show how this works. If we just print out count, actually, let's just say that it's just input right now because this is a bit more simple. So right now, this is just taking an input. And if we run the code on the right-hand side, there's a space for us to type whatever we want. If I type in that and then I print it out, that's what it's going to print out. So this input word is just how we take input. And then Gary was just about to explain how we cast it to a different type.
So again, if I, for example, run again, so now I have an integer input, but what if I put like something like string? It will actually give us an error. So it says, oh, you're not supposed to do that. So if we do like a number, it will actually print out the number back to us. So basically, it was like we're telling that we are taking an integer input, and this is important. Sorry. So this is important because you will need to use the integer later on in the code. So if I go back here, so now I have our integer. Then now I have to do is to take in all of these inputs. So we know that we have integer, right? And then sorry, we have an integer, and we have to take in this many characters. So what we have to do is we have to do a loop, right? Obviously, a loop is better. So we would do for so let's say for I in range of count, and then again this colon at the end. So basically, this tells us that we're telling the computer to run the loop count time. So however many, whatever number count is, will run it that times. And each time we will be taking in the inputs. So the volt that we're getting in will be the new input that we get. And again, the input is a string. So we'll have to store the input as one. So basically it will be all the volts. So all the valid equals to string inputs. So we're storing all of the volts in the valid variable. Then actually we don't repeat this. So all we have to do is we have to go through the specific valids. So again, we haven't learned this yet, but we will have to. We haven't learned this yet, but we have to reference the indexing of strings, which we will learn next class. But basically, how you reference strings is all of the strings will start with index 0 and index like and -1. So basically, it means that the first letter, the index for the first letter is actually 0. And then the second letter is 1, third letter is 2, blah, blah, blah. But we'll go into more in depth for that for next week. But for now, you just have to know that if I do this, it'll basically go through all of the letters inside the word valid. So what we'll have to do here is we'll have to count. So we'll have to write an if statement, right? Because we'll have to see if the person will vote for A or B. Sorry. So I have to do if statement. So if the valid at, how do you represent index at? I don't think it's.
Yeah.
Brackets. So bracket I, if this is equals to, let's say the variable A, sorry, the character A, then we basically give A more volts. But again, how do we keep track of that? So we need two variables, right? First of all, we need an A, then we need a B. So basically, A means that, so by default, A has 0 volts, B has 0 volts. But as we move along with the program, we saw this that, oh, A should have 1 more volt. And so if valid at I, again, equals to B, then we have B, we give B 1 more volts. And then after the end of the entire for loop, all we have to do is we have to see who won the entire race, right? So if A has more volts, that means A won. If B won more volts, that means B won. So if, again, I have to use A. If A bigger than B, then we say that A won. So print A. But if, so else if, so the other condition is that A actually has less volts than B. That means B won, so we do print out B. And then the last condition is if they're tied. So that means, obviously, if none of these happen, that means they're tied. So we have to print out that it is tied. So if we run our program here, sorry. If I run our program here, it's very trouble with Zoom. Okay. So if we run our program here, and we just copy and paste from example input 1. Just have to paste. You can see that we got B as output, which is correct for the first one. And then we put out, if we test the other one, we run again. That's definitely put 2. So it should output tie for us. So we paste it in. And it should output high. Yeah. So now we have to test, we have to make sure that our solution works. So I have to submit our solution. Let me just log in real quick. So you have to click on submit solution. Okay. So you have to select the right language, which in this case is Python 3. So we're using Python 3, which is in the 3rd version of Python. So all I have to do is copy this entire thing and then paste it into here. Click submit. And we should see 5 check marks because we've passed all the test cases. So you should see like a line of green here, and then everything should be accepted. So this is basically how you solve this specific problem. Yeah, but I think there should be there should be another problem that we skipped, which we can leave for homework, I believe. Let me take a look. Where is it?
I think it's lower. It's 39.
Yeah. So this problem we have to skip this problem because we're running out of time. But I guess we can leave this problem for homework as well. So again, CC 2019 Junior 1, and along with these homework slides.
Yeah, so for homework over the next week, just first of all, please sign up for a Dmoj account at dmoj.ca. And if you're asked for a default language, just put Python. And then there are a few problems on here that you can just type into the search. And then if you press go, you'll be able to find the problems. So just try some of these out. These are just kind of basic things to get you familiar with the code. And then this last one is a bit harder. And then just try them out, and then we'll go over them next class as well, as also the problem for the one that we skipped. And Pavan, could you send the slides through an email to all of the participants so that it could be accessed by them? And you can also put our contact information as well. So if you guys have any questions over the next week, just feel free to email us and we'll get back to you with any help. And for the coding for the last problem, yeah, if you guys want to stay behind a bit, I can kind of go through the solution a bit more, because I just realized that we didn't actually learn indexing yet. We'll go over that next week. But a different way to solve the problem is something I can show you as well that we did go over this class. But with that, I think I'll conclude class here for now. If people want to say anything, you can. But if you guys do want to stay behind to learn a different solution that might make more sense, you can also do that as well. But yeah. Oh, Pavan, you're muted.
I just want to say thank you for coming today. Thanks for sharing everything. I will send out the slides and the recording later today.
Okay, yeah, that sounds good. So yeah, if you guys want to disconnect now, that's fine. But otherwise, I'll quickly go through an alternative solution. So on the slides, there was one example of a for loop, which is called a for each loop. And that was using the in keyword to go through an actual like string or an actual list. So we didn't exactly like cover this in depth yet, but because I'll just comment out this code for now, because the ballot variable is a string, we can actually use the in keyword to loop through every single variable of the string. So I guess I'll just go over this now. So after running the code, you can see that if I paste in this input, I print out obviously 6 and ABB because that was the input. So if I use this for each loop, so if I say for I in ballot, so this is looping through every single like character of your string. So in the example with the thing on the console here, because ballot is ABB, it's going to print out A, and then it's going to print out B, and it's going to print out B, and then it's going to print out A, B again, because that's every single, what we call element, every single character basically in this ballot string. So theoretically, this count variable is actually not used, but they give that in the question because other languages do need to use this count variable. But as you can see, I print out I here, and it just loops through every single character of ABB in the string. So then we can apply the same code basically. Instead of using like this ballots of I, we can just reference I itself, because I is the character A or B that's actually in the string. So this is the same code afterwards. So we have if I is equal to A, then we can add 1 to the variable called A. And then otherwise, the ballot is B. We can add 1 to the value of B. And then at the end, we have the same check here. So I'll just copy paste this. we have this as well. And then if you just run this code, you can see that we have the same answer. So these two segments of code, these two for loops, they do the same thing. The only difference is that this one uses the for loop and it references each element of the string, but this one uses indexing to get the element of the string. And here I is still a number from 0 to the range of count, which is from 0 to 5. So I hope that makes sense. If it doesn't make sense, don't worry about it too much. We'll go more in depth in this next week. But yeah, with that, please make a Dmodge account and try some of the practice problems. They should all be, I'm pretty sure they're all solvable with what we learned in class today. But if you do have any questions, feel free to email myself or Gary. Payvan can provide our emails in the same email that she sends the slides out with. But with that, thank you for coming to class, and we will see you all next Saturday.